Hello guys, welcome to AI Martian. This is Krishna, and today we will talk about aggregation operation in TensorFlow because we are working on TensorFlow playlist, right? Or deep learning playlist. So we are going to learn TensorFlow to execute deep learning operation in future, right? So for now, let's go to the Google Colab sheet where we are doing all our code. I already provided the link of a Google Sheet in the description. So let's go to Google Colab sheet and we will start aggregation function there. So in aggregation function, we will start here, aggregation function operation in TensorFlow. So we have three subdivision of this, means three major operation which we'll use in this sequence to learn. Okay, so reduce sum of element across dimension of tensor. So what it is, we will talk about it. Reduce mean of element across dimension of tensor, and the third one is reduce max. So maximum value evaluate dimension of a tensor. We will talk about it one by one, okay, while doing coding stuff. So let's do coding of this. So I'm going to start with this one. So let me clear the window first of all. So I'm going to code the very first scenario, which is this one. Reduce sum. So let me put it here and make a heading. So 3.1, the very first I'm going to mention reduce sum. So what is reduce sum? We'll talk about it. So first of all, I have to import TensorFlow. So let's import it. Okay. So now I have to create a matrix. So let's create a matrix. Let's say a variable A. I'm using tf dot variable function this time because last video I used constant. So I just want to use variable because I want to show you both the demonstration of constant as well as variable. So you guys would not think like only constant is being used by Krishna. So that's why I'm using this tf dot variable this time. So let's say I want to create a 2D array or two-dimensional array. In short, I'm keeping simple values again, but if you want, you can take complex value, no problem. So this is my tensor A. Now I want to use reduce sum. Okay, so how can we do this? So what does that mean? First of all, we will talk about it. So let me execute the whole code, then I will show you what does this mean. Okay, so tf dot reduce sum. Okay, so let's say if I will add all the values, okay, so it will simply give me the sum of all the values. Okay, it will simply add all the values like 1 plus 2 plus 3 plus 4 like this. Let me code it first, then I will explain you how it works. So tf dot random reduce sum, I have to pass a variable which is a. Again, a is a tensor, of course. And if I will hit shift enter after assigning to a variable, let's say result I'm using here, and I will print the value of result, I will get output, which will be this 21, which you're getting in front of it. Okay, and data type is int 32. Okay, so why I'm indicating data type this time? Because it will definitely create some problem while we move to the next step. Okay, like the 3.2 stuff. Okay, 3.2 reduce mean operation, when I will perform with the same tensor, it will execute, it will create some problem there. So that's why please keep in mind its data type is int 32. Okay, now what happened, let me explain you. So in this scenario, in reduce sum, simply it took all the values 1 2 3 4 5 6. So what happened, it simply took all the values and add them. That's it. This is the only operation happened here. Okay, but this is the not only yet, means we have some parameters over here which we have to pass inside this. Okay, so I will pass that parameter as well. So if you will add this all value, like 1 plus 2 will become 3, 3 plus 3 6, 6 4 6 plus 4 10, 10 plus 5 15, and 15 plus 6 21. Okay, if you are not sure, please do calculation using calculator. So this is the operation only happened here, and this is the output which you are getting is here, you can see. Okay, and the shape is nothing, means it does not have any square bracket around it, and that's why it is empty. means there is no element, because means this is a tensor but a scalar tensor. Okay, scalar tensor. Okay, so let's move to its subdivision, means how can we pass parameters. For example, now in this tensor only, I want to add this value and this value separately. Okay, so it will be like a 6, and it will be like a 6, 5, 11, and 4, 15, right? So I want these kind of values separately. Okay, so how can I get this? So let's do this. So it's simply add the values in each row separately. Okay, such kind of heading I'm going to create, and I'm going to use same value, which is print the first tensor which I created. So let's say I want to add these value separately. Okay, means I want to add them row wise. So I have to pass tf dot reduce sum, and I have to pass here a, which is my tensor, and then axis is equal to 1. It will add all the values row wise, and I'm storing inside a variable called result1, and print result1. It will give you two values. Okay, so the first value is 6, means if you will add these values, it will return you 6. Okay, and if you will add these three value, you will get 15. Okay, so this will give you a row wise kind of addition. Okay, separately inside an array or tensor, you can say. Its shape is 1 because there is one element. Okay, and you can see at the outermost it has one bracket also. Its data type is in 32. Okay, so if you want to add column wise, let's say I want to add uh let's say I want to add these two value. Okay, 5, these two value, 7, these two values, 6 plus 3, 9. It will return you inside a bracket. Okay, or tensor. So you can do it just by replacing this 1 to 0. Okay, so how can we do this? Let's do it. So I have to simply mention result 2 is equal to tf dot reduce sum, and I have to pass a, and axis this time will be 0, and print result 2. You will get three values this time. So 5, 7, and 9. If you will add these values, you will get 5. See, this is 5. This is 5. If you will add these two value, 5 and 2, 7. See, we are getting 7. If you will add these two values, 6 plus 3, 9. You will get the all values from this tensor on. So it is also in the form of tensor. Again, its shape is one dimension because there is one bracket at the outermost, and we are getting one element inside this. This 3 is only the number of elements which we are getting inside this tensor. Okay, and its data type is also in 32. Okay, so this is the way how we add our values row wise and column wise. Okay, so if you want to add your value row wise, you have to simply mention axis is equal to 1. Let me make a note of it. To add values row wise, axis is equal to 1. Okay, and if you want to add column wise, to add column wise, you have to put axis is equal to 0. So these parameters you have to take care about. So let's move to third operation, which is reduce, which is reduce mean. Okay, so let's go and create one more heading here. Let's go and create one more heading here. So I'm simply putting a comment and I'm making it heading. So reduce mean means mean of element across dimension of a tensor. Okay, so it will create some problem. Let's see what kind of problem we will get. So first I'm showing you error. What kind of error we will get? Error we will get. Let's see. So I want to use the same tensor, A tensor, which I created earlier. Okay. So I'm using same tensor and I want to calculate the mean. Mean means what? Let's take an idea of mean first of all. Mean means you have to add all the values and divide it by total number of elements. For example, 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by total number of elements. So 1, 2, 3, 4, 5, 6. 6 elements are there. So you will simply divide the whole value after adding by 6 and you will get some mean. Okay. That is called mean or average. Okay. So you will get these by simply adding all the values and divided by the total number of elements. So this is the mean. Okay. We will calculate it. Let's see how can we calculate. So I'm calculating it. So mean 1 is equal to tf dot reduce. We have inbuilt function in TensorFlow mean. Okay. So I have to simply pass our tensor, which is a. So if we will calculate mean, we will get a floating point number, but we are not getting floating point number. Let me print the mean. And we are not getting floating point number. We are getting 3. But 3 is not the output. Okay, let's think about it. How you are saying so it is not the output. So let's add this 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, and if you will add them and divide by 6, you will get a floating point number 3.5. This is the mean. Okay, but you are getting 3. Why we are getting 3, not 3.5? Why we are not getting 3.5? This would be the question. So here we have to take care about int 32. Data type is int 32, and int means it will remove all the floating values. Okay, it will simply remove dot and their values. Okay, so it's simply int 32 remove all the values and returning us only a integer value, which is 3. So what can we do? While creating this tensor, we have to define data type there. Okay. So how can we do this? So let's create one more tensor and we will implement the same. So I'm creating same tensor. B is equal to tf dot variable, and I will use a matrix. Okay. So I have to pass, let's say 1, 2, 3, 4, 5, 6. Okay. So this is the value I'm getting. And here I have to pass data type. So data type is nothing but D type you have to mention. And so because we are using TensorFlow, we have to, we have to mention tf dot float 16. Okay. Float 16. So once you will hit this shift enter, you will get the value or the tensor B. Okay. Every value is in the form of float. See 1 point, 2 point, 3 point, 4 point, 5 point, and 6 point. So now if you will calculate the same mean, okay, so you have to simply mention tf dot reduce mean and you have to pass your value B, and you will save it inside, let's say mean 1 is equal to, and you will print the mean 1, you will get a floating point value that is 3.5. See, we are getting 3.5 this time. So this is what I want to tell you. Like you have to consider about data type as well, because if you will create a tensor, okay, so by default the data type will be into 32, means integer. So you have to convert that integer to float if you want to get the accurate answer. Okay, and see, I'm getting accurate answer now. Initially I was getting 3. Okay, not 3.5. See, 3. Okay, but now I'm getting the accurate answer, which is 3.5, which is our mean. Okay, now again, if I want to calculate the mean row wise or column wise, how can I do this? So same operation I have to do. I have to pass x there also. So calculate mean row wise. Okay, row wise. So I have to simply mention tf dot reduce mean, and I have to pass b there, and I have to pass axis is equal to 1, which is row wise. Okay, so you have to store it inside another variable, let's say mean 2. Okay, because I already create a variable mean 1, that's why to make it a little bit different, I'm using mean 2 this time. So it will give me the mean according to column wise. Okay, so let's see how can we get it, how can we calculate manually, just to understand. Okay, so if you will see this row and this row. Okay, so here we have 3 value in this row. Okay, so if you will add 1 plus 2 plus 3, you will get 6. And how many numbers are there? So 1 2 3 numbers are there. If you will divide it by 3, you will get 2. Okay, so 2 is your very first number. See, because this is float 16, that's why we are getting point here. Okay, and again with this row. Okay, so 4 plus 5 plus 6. Okay, so 4 5 9 6 15. 15 divided by 3, because we have 3 element 1 2 3, so it will simply return you 5. So that's why we are getting 5 dot. See, because this is float again. All right, so this is how we calculate mean row wise. Okay, again now I want to calculate mean column wise. How can I do this? So in mean wise you have to simply 1 plus 4, add them and divide by 2. So it will give you the first mean like 2.5. The second mean will be 5 plus 2. So 5 plus 2 7 divided by 2, because there are two elements. So 5 plus 2 divided by 2, it will give you 7 divided by 2, which is 3.5. Similarly, the third. Okay, third column, 3 plus 6 will give you 9 by 2, and 9 by 2 once you will calculate, you will get 4.5. So here I will get 4.5 inside a square bracket. So this is also a tensor. We will get column wise if we will calculate the mean. So let's calculate it. So I'm cleaning the window for now. So here tf dot reduce mean, and I will pass b, and axis will be 0, because I want to calculate column wise, so axis will be 0. So I will also store it inside, let's say mean 3 is equal to, and I will print mean 3. I will get the output, and that is 2.5, 3.5, and 4.5 we are getting. And its dimension is also one dimension, because there is only one element inside this shape tuple, and data type is float 16. So we have to keep this thing in mind, all right? So let's move to third operation. Reduce max. Okay, so what is reduce max? We will see. Let me create a heading first of all. So when I will provide you this seed, you guys will able to differentiate each and every code as per their heading. Okay, so let's take the tensor b. Okay, I'm doing operation on the same tensor. Reduce max. Okay, so we are simply trying to get the maximum value. Okay, in the whole see, there are three kind of approach I'm telling you each and every time. The first one is i'm calculating i am calculating I am calculating whatever mean, sum, and max value. Max value. Okay, so reduce max is nothing to only to calculate maximum value from the tensor. Means this is the tensor, right? So I have to calculate maximum value, which is the maximum value. So 6 is the maximum value. It will simply give me that. So this is the maximum value with respect to the whole tensor. Okay. But now if I want to get the maximum value according to row wise, so this is the maximum value for the first row. And in this row, 6 is again the maximum value. And what about the column wise? Column wise, we have 4 is the maximum value. And in this column, we have 5 is the maximum value. And in this column, again, 6 is the maximum value. So we calculate maximum value or mean or sum, whatever it is, in 3 ways. First, in overall tensor, then row wise, and then column wise. So for a overall tensor, we do not pass any kind of axis. We are not passing any axis. Okay. We are not passing any axis for overall scenario. Okay. But for a row wise, we are passing axis is equal to 1. And for column wise, we are passing axis is equal to 0. For row wise, to calculate row wise, we are passing 1. And for column wise, we are passing 0. Okay. So these things keep in mind always. All right. And let's implement the same. So TF dot reduce max. Okay. This is to calculate maximum value from B. Okay. I'm passing this B tensor over here, and I will save it in max 1, let's say, and I will print max 1. Okay. It will simply give me 6. Okay. So see, 6.0 I'm getting. All right. Now its shape is nothing, means it is scalar tensor, right? There is no dimension. It has 0 dimension. That's why shape parenthesis doesn't have any kind of element inside it. All right. Now I want to calculate row wise. So again, max 2 is equal to TF dot reduce max, and I will pass B again the same tensor. Axis will be 1 because I want to calculate row wise, right? So row wise, I will get 2 values, okay, inside one tensor. So I have to simply print the value of max 2, and I will get 2 values. See, 3 and 6, and it is inside of square bracket, right? That means there is one square bracket at the initial position. So that's why its dimension is 1, and we are also getting one element inside this tuple or parenthesis. So it has only one element where it has only one dimension, whereas the number of element is 2, which is mentioned by this magnitude only inside this parenthesis. And its data type is float 16. Again, if I want to calculate a maximum value column wise, I can do that. So I have to simply mention TF dot reduce max B, axis is equal to 0. I have to pass. All right. And I have to print max 3 there. And I will get 3 values this time inside a square bracket or tensor. So see, we are getting 3 values inside this tensor, one dimension array. Okay. Or tensor. So it is simply telling us like there is one dimension because it has this shape. This tuple has only one element inside it. That means one dimension. Or we can also check here, like there is only one bracket at the outermost, so that means it is a one dimensional array. And this 3 is telling like there are 3 elements inside this tensor. Okay. And its data type is 60. All right, guys. So this is all about the aggregation operation in tensor. So hope you like this video. If you like this, please do like, share, subscribe, and share with your friend, family. And thank you very much. Thank you, and have a nice day.